Good morning, all. So I'll start. The presentation is loading, I think. So thanks GT for inviting me to present the keynote today. I think there are 2 days exciting presentation lined up for the upcoming sessions. So I stand before you to talk on the topic that resonates deeply, the transformation shift towards electric vehicle, which is the leveraging system simulations for EV revolution. Before going into the topic, I just want to give a heads up about OLA. OLA, we started from a ride-hailing company. We redefined the ways that million people commute to the cities through just a press of a button with a ride-hailing platform. From there, we thought of building the sustainable future for the world from India. That is the key initiative began starting off OLA Electric. In OLA Electric, we have started our Gigafactory, the OLA Future Factory, which was groundbreaked at March 2021, and we sold the first vehicle in December 2021. Along with that, we understand that the cell are the key art of electric vehicle. We also have our world's largest battery innovation center, and along with that, we will be making our Gigafactory operational by 2024. With that, we wanted to make EV revolution across the globe. We wanted to build the product for the world from India. This is just a glimpse of a future factory. This is spread across 400 acres in Pochampalli in Tamil Nadu. So this is a completely automated manufacturing facility. So this video, many of you might have seen this video online. Just wanted to run it through. This is a battery line which is completely an automated process from cell placing till EOL testing, and also there are well lines which you will see in the coming videos where it is all automated. So you see the well line is also completely automated in our plant. To just keep the time, you just skip this video. This video is online available. So before starting a presentation, I want to say about the growth of EV in India and the globe. In 2022, the EV was just 1% across the globe. But we see a drastic growth in the recent years. It has increased 6 times, and now we see a EV penetration of 6% across the world. In major urban cities like Bangalore and Pune, we see close to 20% of the vehicles are already converted into EV. EV revolution is not only happening across urban cities, but also we see pan-India. OLA Electric contributes to 25% of the EV electric vehicle scooter which are sold last year in the country, and we are close to 40% market share in the recent months. So why the future is towards EV? There are close to 40 lakhs Indian purchasing two-wheeler every year. India is mainly thriving on humans which thrives for two-wheeler for the day-to-day commute. Comparing EV to traditional petrol vehicle, they have a very less maintenance cost. Basically, they are 1/10 of the cost of traditional ICE vehicles. So when we see that there are some barriers around the EV in order to adapt it. One is the range anxiety, the other one is the charging and the charging infrastructure around the EV, and the last one is the life or the life of the battery of the electric vehicle. So with OLA, we want to break these barriers. So we are planning to have 10,000 plus charging stations in India within less than 3 months, and we have a variety of products ranging in OLA which starting from 79,999 to all the way to 1,45,000. This helps us to have a variety of products, and we also have the charging infrastructure in place, and we also have a very good warranty for our electric vehicles. So with that, we will be able to break the barriers of electric vehicles so that we will be ending the ICE. So next I want to talk about the system simulation, how system simulations help in EV revolution. As we stand in the forefront of EV revolution, system simulation helps to address some of the most pressing challenges of EV. Basically, the interaction effect of different systems, how they operate in an electric vehicle. The main components of an electric vehicle are battery, as you know, the motor, the controller, and the charging system. These multiple systems need to interact with each other in a seeming way in order to give a good performance and also with an optimum efficiency. There are multiple modeling needs to be done on the battery simulation. For example, we will be able to model you.